Check it.
Okay, welcome back. Today we're going to be learning a new factoring method called factoring by grouping. Now, we've been using factoring by grouping as part of the AC method for a long time now. We're just going to expand upon that for scenarios other than the AC method. Factoring by grouping works when you have a groupable number of terms. So let's say you have 4 terms. You could group this into 2 sets of 2, right? That's 2 equal sets of 2. That's groupable, okay? And you might be able to factor by grouping. So let's say you have something with 6 terms. Well, 6 terms could be 3 groups of 2, or it could be 2 groups of 3, right? It could be 3 and 3. So you have options, okay? And the answer comes out the same regardless of how you group, but you have to have a groupable number of terms. Like here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. 9 terms, you don't have too many options. It's going to be 3 groups of 3, right? Because it can't be, odd numbers of, they all have to be the same number of terms in each group. So the only real group here is 3, 3. So it doesn't have to be an even number of terms. It just has to be a groupable number of terms. 9 is an odd number, but you can have 3, 3, and 3. Now, the way I circled this, these aren't going to be the correct groups because you're going to have to rearrange things in order to do the grouping. But I'm just showing you, you're looking for a groupable number of terms. If you have a groupable number of terms, so by the way, when we were doing trinomials, and we had something like 3x squared plus 6x plus 1. Okay, that's not factorable, but we would not try to factor this with reverse FOIL. We'd try to use AC method. And the reason why we use AC method is we'd multiply A times C, and then that would help us split this into 2 terms, and then we'd have some, and this is totally wrong, but just to give you an example, we'd have 4 terms, and then we could group this into 2 and 2, and that's the AC method. It's just basically finding a way to make a trinomial into a 4-term polynomial so you can factor by grouping, okay? So we're going to factor by grouping, but we're going to do it with, as you saw below, up to 9 terms here, okay? Most of the textbook problems are 6 terms, but I'm going to show you how to do everything anyway. Okay, so this is basically what you would do if you just started the first half of the AC method and now you have 4 terms. And what you do is you group together the first 2 terms and the last 2 terms. Now, in the AC method, you always have the same one letter all the way across. Here we have different letters, M and N, X, W, K, Y, all kinds of stuff here. So the first one we're going to do is the most familiar one. The first one only has X's. And usually what you do is when you have only one letter, you arrange it in highest power to lowest, and you group together the first 2 terms and the last 2 terms like we've been doing for AC method. And you look for a GCF. So we're going to do that. You take the first 2 terms, look for a GCF, take the last 2 terms, look for a GCF, and you hope that what's in the parentheses in both cases is the same. So let's see how that works. What's the greatest common factor of the first 2 terms? Now they both have a 2 in them, and they both have an x squared in them. So you can pull that out. And what's left inside is going to be 6x plus, well, just 1. And you double check that. That times that equals that, and 2x squared times 1 equals 2x squared. Yes, that works. Now, in order for this grouping to work, this has to be 6x plus 1. It has to be. So now your job is to figure out what number goes here that when you distribute it to 6x plus 1 gives you negative 30x minus 5, and that would be negative 5. Check it, it works. And now that these 2 parentheses are the same, the 6x plus 1 is now the greatest common factor for these 2 terms, so you can factor it out, 6x plus 1, and the stuff outside makes the other factor, 2x squared minus 5. And there you go, that's the factorization. So you'll recognize that as being the second half of the AC method. That's nothing new. That's what I've written here. Okay, but now we're going to take it further. What happens if you don't have all the same letter? So multivariable. Now it's really important for these problems, especially in the homework and on any quizzes, that you show your grouping first, okay, your proper grouping, you show all your steps, and you don't just show a final answer, okay, if you want to get your points. So let's take a look at this. We have 4 terms here, And you don't just blindly use the first two terms and the last two terms. The reason being is that might not work. So what you want to do is you want to group them in such a way that you definitely have at least one term that you can factor out, some greatest common factor. So if I did choose the first two terms, is there a GCF? Yeah, 4 goes into both of these and M goes into both of these. So 4 and M goes into both of these. If you look at the last two terms, however, they don't have any letters in common, but they do have a 7 in common. So there's something, okay? Now, let's say this wasn't a 28. Let's say this was a 23 or something like that. You would not group these together because they have no GCF, no common factor. So that's the whole point. You have to make sure you're going to get something out of this. Now, since they both have a GCF, I'm going to go ahead and give it a try. So we said that this was going to be 4M, okay? And what's left is going to be 4N minus M. Okay, double check that, it works. Now, in order for this to work, you're hoping that you're also going to get a 4N minus M here. And it looks like if I just multiply by, it looks like positive 7, that 7 times 4N is 28N and 7 times negative M, yeah, that works. And you can see, there you go. So you have 4N minus M is one factor. It's the common factor in the two terms that we have here. This is all one term and this is all one term. And its common factor is that. And then the stuff outside makes the second factor, 4M plus 7. And there you go. That's factoring by grouping with two different variables. The important thing is when you do your grouping that you have something to factor out. You have a GCF. In this case, you had a 4M coming out of these two, you had a 7 coming out of these two, and that was good enough. All right, now we get a little more complicated. Still 4 terms, but more letters, okay? And the fact is you can group this a few different ways, and you'll get the same answer each way. For instance, I could decide I'm going to group by X's and Y's. Okay, if I do that, this is already set up for that, meaning this has an X, this has an X, right? And this has a Y, and this has a Y. So I can group together these two, and I can group together these two, and I'm guaranteed to get a greatest common factor of X from here and Y from here. I can do that. But there are other ways I could do this. Like for instance, let's say I use K instead. Okay, there's a K here and a K here. So I can group those two together, okay, and write this down here, 49xk squared minus 21yk squared, okay? And then this one here has a W, and this one here has a W. I can group those together. So plus 56xw minus 24yw. And I can group according to the K's and W's now. All right, so that, and this will work, and this will give me the same answer as if I use the X's and the Y's. So let's actually go ahead and do both really quickly. I'm going to breeze through both real quick. So what I'm going to do is zoom out a little bit and put these next to each other. And we'll do one, we'll do the other, we'll compare answers. So let's do it the way it's already written, which most people would just go ahead and use what's written already. But like I said, don't blindly just do this because it might not work in the order that it's written. You have to check it. But in this case, yeah, there's definitely an X here. So we're going to take out X from both of these. And what else can we take out? Can we take out any other factors here? So this, 49 is 7 times 7, and 56 is 7 times 8. So actually we can pull out a 7 as well. There's a common factor of 7 here. And what we get is 8 W plus 7, and we're pulling out an X here, so just K squared. So the hope now is that when we do the same thing here, when we take the GCF out of these two terms, that there's going to be an 8W plus 7K squared in there. And let's see, what would make this work? It looks like -3. -3 times 8 will give you -24. Oh, no, we need more than just 3. Y and a Y. Okay, -3Y. And that will give you this. And -3, 21Y, yeah, okay. And so yeah, this works, and you can see it's going to be, the answer is going to be 7x minus 3y as your first set of parentheses, and your second will be this thing right here, which is 8w plus 7k squared. And there's your answer, okay? And now we'll try it if you had grouped it according to the k's and w's instead of x's and y's, okay? So we'll try it the other way. I'll try to keep both on the screen here if I can. And all right, so the first two here have the k squared in common. right? And they also have a factor of 7 because 7 goes into 49 and 7 goes into 21. So it's 7k squared is your common factor. And this is going to be a 7k, no, sorry, not 7k, 7x. And it's going to be minus 3y. And if you distribute this, you will get this. Now the hope is that when you do the same thing here, you'll get the same 7x minus 3y. What would make that work? Well, what times 7 will give you 56 would be 8. And also xw, so there's a w here. And it's positive. And I don't know why I made the 8 so close to the parentheses there. But you get this. And now you can see this is going to be 7k squared plus 8. 7k squared plus 8w times this thing here. 7x minus 3y. And if you compare the answers, they are the same. It's just that they're just written slightly differently. Like this is 7k squared plus 8w. This is 8w plus 7k squared, which is the same thing. Okay, and the order of the parentheses is different, but it's still, you know, multiplication is commutative. You can, a times b is the same as b times a, so it doesn't matter what order the parentheses are in. But you can see, no matter how you group things, there's no wrong way to group as long as you do get a GCF from each group. Okay, so this next one has 6 factors, 6 terms I mean, and once again, I've been saying this all along, but there's a tip written here. Rearrange the terms so they have at least one group in common. Now, because this is 6 terms, you can group as 2, 2, and 2, right? Or you can group as 3 and 3, 3 and 3, like that. The question is, which are you going to use? So once again, let's say we just took the first 3 terms. If I took the first 3 terms, okay, you want to make sure you have at least one variable in common for all 3 of these. And let me see, ax, cy, bx, they have no letters in common. Okay, like this one has an a, but these two don't. This one has an x, but this one doesn't. You need something where they all have the same letter. So this grouping this way is not going to work. Okay, the first and last 3 are not going to work. What if you went 2 and 2? Well, there's no GCF here. I mean, aside from the numbers, you can pull a 2 out of both of these, but the letters are totally different. So you're going to have to rearrange. There's no way around this. Okay? If you're going, so look at the letters and pick. Say, all right, I want to group together all the A's, for instance. Well, here's an A, and here's an A. There's 2 of those. And then let's say I want to do all the B's. Here's a B, and here's a B. That would be 2 and 2. And then let's say I want to do all the C's. Well, here's a C and here's a C. So that would be 2, 2, and 2. I could do that. Or I see an X and Y in here. What if I did X's and Y's? Well, there's an X here, an X here, and an X here. So that'd be 3, and there's a Y here, a Y here, and a Y here. So that'd be 3 and 3. So I have a choice. I can either use A, B, and C and have 3 groups of 2, 2, 2, and 2, or I can use X and Y and have 3 and 3. Either way, it's going to work. Okay, I guess it'll probably be easier if you just choose a less number of groups. So let's just go ahead and do the X and Y thing. So let's take all the X terms and write them next to each other. So 12ax squared minus 18bx squared plus 24cx squared. That's all of the X terms. And now all of the Y terms, so I put the red arrows on, I'll write those in red, minus 20cy squared minus 10ay squared plus 15by squared. Okay, and now you can see it's going to be 3 and 3. Okay, and now so what's the GCF for the first group here? You can definitely see an x squared goes into all of these, right? So factor out an x squared, but also what else? 12, 18, and 24, 6 goes into all of those. So I'm going to use a 6 here as well, 6x squared. And now what are the 3 terms that we get in here after we pull out 6x squared? So 2a minus 3b and plus 4c. And check yourself as you go. So multiply that. Do you get that? Yep, yep, and yep. Okay. Now over here for the red, definitely a y squared comes out of all of these, right? And you also see a 5 will go into all of these, right? Okay. Plus or minus we'll determine in a minute. But what's in the parentheses? Well, in the parentheses, we're hoping we get the same thing that we have here. 2a minus 3b plus 4c. But we'll find out. If you pull Let me start by just doing a positive 5 and see if that works. I might have to change to a negative in a second. But if I pull out a 5y, this becomes negative 4c, negative 2a, and positive 3b. And if you look at the two sets of parentheses, they don't match because the 4c here is positive, but it's negative here. The 2a here is positive, but it's negative here, so on. So everything is the wrong sign. So I guess what I should have pulled out is not a 5, but a negative 5. So I'll fix this. I'll make this a negative 5, okay? And that'll change the sign of all of these. That becomes positive, and this becomes negative. And now you do see that the two parentheses are the same. They're just not written in the same order, but they are the same. It's 2a minus 3b plus 4c, 2a minus 3b plus 4c, same thing. Okay, so that means I've successfully grouped these together. If the parentheses match, you're in good shape. Now take the two outside terms, put them in one set of parentheses, and take whatever the common parenthesis thing is. I'm going to do, alphabetically here. So 2a minus 3b plus 4c, and you're done. Now, if you had grouped it as 2, 2, and 2, that would have still worked. Okay? All right, so let's go on to this last one here with the 9 terms. Okay, this is a biggie. All right, so what letters, can hardly fit it on my screen. What letters do we have here? Well, we have A, B, C, and we also have X, Y, and Z. All right, so we have and we're definitely good. We already said we're gonna use, because it's 9, the only way to group this evenly, you can't do like 4 and 5. You have to do 3 groups of 3. So 3, 3, and 3. So you can either use A, B, C, or you can use X, Y, Z. It's up to you. Now, since last time I used the X and the Y, this time I'll use the A, B, and the C. Why not? So let's see. I have an A here. I have an A here. And I have an A here. So that'll be one group. So we'll do 6a squared x squared. That's that one there. 5a squared y cubed, and 2a squared z squared. That's one group. The second group I'll do is the b's. So there's a b there, there's a b there, and there's a b there. So the b's I'll do in blue. And then finally the c's we'll do in green or something. There's a c there, there's a c there, and there's a c on the end here. So we got minus 15c squared y cubed, 18c squared, that thing, and squared. All right, so we have our 3, 3, and 3, and they're grouped according to A, all B, all C. I could have also done X, Y, and Z if that gave me 3, 3, and 3. Doesn't matter how you do it, it's going to work out the same. Okay, so let's drop the colors and just do the factoring now. What is my greatest common factor for the first 3 terms? Well, I chose them because they all had an A in them. Okay, specifically an a squared. So I can definitely pull out an a squared. But is there anything else? You have to check. Well, no other letters in common and no numbers, 6, 5, and 2, no letters. So that's it, it's just gonna be a squared. And if I pull out an a squared from each one of these, what's left is 6x squared minus 5y cubed plus 2z squared. Now the hope is that I get that same pattern, okay, that same set of parentheses 2 more times. That when I do the GCF for these 3 terms, I get the same parentheses. But let me not assume anything. Let me actually just go ahead and do this. So for these terms right here, I definitely have a b squared. Okay, and I will put a plus or a minus here in a minute. But also, what else? I have 20, 24, and 8. Definitely, let's say 4 goes into all of those, right? So 4. And let's see what we get. So let's assume that it's positive for the moment. And just to keep these in the same order, x, y, and z, I'm going to do the x term first here. So what would I multiply by, if I pulled out a 4b squared, I would have negative 6x squared. Now you can see already that that's positive and that's negative. So actually I think this should be a negative 4. So let me back up a step here and say, all right, let's make that negative 4. If I do that, then this becomes positive 6x squared, just like this one. That's good. And now we want to do the y term next, which is this one over here. If I pull a negative 4 out of 20, that makes a negative 5, right? Negative 4 times negative 5 is positive 20. There's the b squared and then y cubed, which does match this. And then finally, if I pull out a negative 4b squared out of negative 8b, whatever, I'm going to get plus 2z squared. And you can see those match. So far, so good. Now the last one on the end here. All right, so we definitely have a c squared coming out of all these. So I could put the c squared down. And any numbers here? Yeah, they all divide by 3. So put a 3 here, because 15, 18, and 6 all have a 3 in common. And now the only question is it positive or negative? So once again, I know that I need the first term here to be 6x squared. So where's the x squared term? It's in the middle here, right? 3c squared times, well, if I pull it out of this here, I get 6x squared. It's already the right sign, so I don't need to put a negative here. This is positive. Okay? And like I'm kind of like getting ahead of myself, and you could go ahead and do it, and if it doesn't match, you can change the signs like I did on the last problem. But if you can see it coming like what I'm doing here, I'm like checking ahead, then you can avoid having to erase. Anyway, so I did the x term first. Then we want to do the y term, just keeping the same pattern here. So we'll do the y term now here, which is you're going to pull 3c squared out of here, you're going to get negative 5y cubed. And you're going to pull 3c squared out of this, which will give you 2z squared. And you see all 3 parentheses are exactly the same. That means we did this right. So take the stuff that's outside the parentheses, which would be a squared minus 4b squared plus 3c squared. All the stuff outside makes 1 factor, okay? And then the stuff inside the parentheses is now the new GCF, that it makes another factor. And we are done, okay? If I had grouped these by x, y's, and z's, eventually I would have gotten the same answer. So it doesn't matter how you group as long as you do group. And I need to see your grouping. I need to see how you rearrange things first. This is an important first step. And then I need to see this, all this work right here. And then finally you box your final answer, 3 points. Okay, we're done. See you at the next video.
Check this.